I am a blue box. Pop. All right, guys. So Nikisha's got a question. Let me put it up here. Oh, so 5A?
Yes.
Okay. So this is perfect. So can somebody tell me 5A, what is it currently solved for? And that's an expression I've used a few times. All right, I got somebody chatting at me. Let me see. Oh, there, yeah. So it's currently solved for K. Does everybody see that? So what does it mean when I say currently solved for? It means which letter is already by itself. So somebody's already solved this thing for K, and they're asking you, oh man, I want it solved for Y instead. I want Y by itself. So now you want to take this equation and try to get that Y by itself.
Okay.
Okay, I like it. How's everybody else? Any other questions from anything? Or Nikisha, if you got another question?
No.
I'm very curious if you guys have started 3.5 yet. This is where I really think there's going to be some questions if you get into this. Some of these get a little interesting. I'm ready for people to get into that and give me some questions. Okay. So if there are no other questions.
I have a question on number 3.5, number 7.
All right, let's take a look. Oh, this is fantastic. All right, so this one is kind of nifty, and it's not a bad idea to draw yourself a picture, right? So let me let you guys read through this a little bit if you haven't gotten into this yet.
Yeah, I had to draw a picture for this one.
Mm-hmm.
Yeah, I don't know how else to really get a feel for what's going on without drawing a picture. So it's 60 foot by 26 feet. And you're going to, around the pool, just right on the edge of the pool, you're going to put these 1 foot squares. So there's just one thing to consider, and if you don't draw the picture, you could easily miss it. So let me just do one piece of this. So let me see. Let me get the attempt to draw. Let's see what I can do here. Oh, I can do this. Here we go. This will help me out. Shwa! There we go. Yay. Sorry. Y'all know if I try to do this freehand, it's not going to be pretty. So this is 60 feet here, and this is 26 feet here. So if I put a tile right here, and I keep doing that, can somebody, and there are 1 foot squares. So it's not that difficult to figure out how many would be along this edge here total then.
Right. Okay.
And then you start here, but all right, so right there, and then you can tell how many is going to go there. The first couple of steps of this, once you draw the picture, are not difficult.
I drew the picture and I got the perimeter.
But what about right here?
Oh, plus the one in the corner.
Yeah, so there would be, yeah, all right. That's all I'm going to say.
Okay.
Especially if you haven't even tried this problem yet. Now you've got a nice place to start. And, once you get number 7 done, I think the next question is built off of what you've done. Oh, shoot, let me see. I'm going to clear this drawing now. Hopefully everybody's got the drawing. I'm going to clear this away. Bam. Because the next thing they want to know is generalize your result from question 7 because what you're going to get from question 7 is based on the 60 foot by 26 foot. So now the next question is, what if it was some other dimensions? Is there a quicker way than having to draw a picture every time? Which is, of course, what we keep saying math does. Math looks for patterns, so it makes it future work easier to do. All right, but if you can't get number 7, you definitely can't get number 8, but hopefully that one's better now for number 7. I like it. So I told you, we went over the examples of word problems, and I told you to watch out for this section because some of the questions are not going to be real word problem. Number 7 is not a word problem question. It's draw the picture and see what happens question. All right. How's everybody else? You guys all right? Any other questions? Okay. All right. So what I want to do then, if there are no more questions, I want to remind you guys, last time we got through section 3.6. 3.6 was interesting because it's built off of things we've done already, which is always nice. And it was this idea of direct variation, which can somebody remind me, there's this really nice example here. Let's see where you went to. Does somebody remember which one of these was not direct variation and why? We did this problem yesterday. Which one was not?
Didn't start there, 0, 0 there, right?
Yeah, this guy, number 24. He doesn't go through 0, 0. I like it. So that means, what does that mean? What would the Y-intercept be for 23 and 25? What's the Y-intercept for 23 and 25?
Zero something like.
Well, not 0 something. You can tell exactly what it is. What point is that they go through?
0.
Yeah.
Now remember, a point's got 2 parts. 0, comma,
0.
0. I love it. So that's the origin. I love it. That's basically what Linnell said, but I just wanted it as a point. And 24 is going to be, now I think this might be what you're referencing, Wasan. 24 is going to be 0 something.
Yeah.
So
I mean in X, I mean, where is going to the X? Like which point it's an X?
yeah, on X, like this one, X is 0, Y is 0. This one, X is 0, Y is 0. This one, when X is 0, Y is something else.
Mm-hmm.
I like it. All right. Okay, so that's what we did yesterday. We basically finished section 3.6. So I want to kind of get into 3.7. We're going to step through 3.7. 3.7 is going to bring a lot of what we've done together. And I've already shown you a part of what 3.7 gives us. Oh, let me see. Where are you at 3.7? Here we go. And all right, so the first problem, they get a little preachy sometimes in this book. I don't know if you noticed it, but obviously you shouldn't drink and drive, but they're a little heavy on it here. But this is an interesting question. What do you guys think about this? Does anyone know if you drink, how does alcohol leave the body over time? Meaning, does it leave the body at a constant rate? Does it leave the body quickly and then slow down? We might not have any idea. I don't know.
I believe it's a constant rate, I think, if I remember correctly.
All right, we're gonna find out. And then we're gonna do what the book wants us to do. And then we're gonna fact check the book. This is always a good idea, right? You want to fact check the book, you want to fact check me. So I want to do this assignment they give us here a little bit out of order, just to make some better points. So read through this setup here about the pizza. And this should feel very familiar to stuff we've already done. All right, so I'm going to take, I want to skip the first couple of questions. I'm going to do this in a little bit different order. I have an ulterior motive. So I'm going to write down some of the key data that they gave us. So it was $9 a pizza. And we had $175 total to work with. Now, number 3, I like this. We can create this table without doing any real algebra, right? If I get 0 pizzas, how much is it going to cost me?
$0.
$0. It's crazy. That's crazy. If I get 5 pizzas, how much will that cost me?
45.
45.
45. And let me do one thing. Let me pull this up a little bit so I can get that graph on here. Let me start over a little bit. See if I can get that sucker on here. Yes, I like it. So this is 0, this is 45, because it's $9 a pizza. And of course, if I just keep going, this will be
90.
90. How much did that go up by right there?
45.
$45, and which makes sense because the number of pizzas went up by 5. So 45 divided by 5 is $9. That's the amount that it goes up per one pizza. But since we're stepping up by 5 pizzas, it's going to step up by 45. So that's another step of 5. So what's another way I can get what goes here is I can just add 45 to this. And if you want to double check that, what is 15 times 9? What do you guys get when you do that? What's 15 times 9? There's the
135.
135. Yay. So real quick, just finish out the last 3 here. So now you got kind of 2 ways to do this. Now, I just have to keep multiplying by 9, but you can also double check. And sure enough, this goes up by $45. And if I go up by another 45, that would be 225. And if I double check, 25 times 9 is 225. Check. And then, of course, finally, 30 times 9 is 270. Now, remember, we had $175 total budgeted for pizza. From this table, can somebody tell me roughly how many pizzas it looks like I can get? Yeah, I could definitely get 15. Yeah, good. I love it the way you guys have. I can definitely get 15. 15 would be safe, but I could get more.
Yeah.
Right. So X equals
Roughly
15 pizzas. I like it. And then Vu said, and I think Linnell just said, it's got to be less than 20, because if I go to 20, then I'm over. I like it. Now, are we not going to tip this poor person bringing out freaking almost 20 pizzas? So we probably, so in real life, we have to make sure we got money for tip and all that kind of stuff. Are you guys with me? That's going to kind of come into play here in a minute. All right. So that's old news. We've done that before. Now just take a quick minute and graph this bad boy. What should the scale be on the x-axis looking at the inputs here? What scale should I use on the x-axis? What do you guys think?
5?
Yeah, so the x is going to be the pizzas. That's the independent variable. And the y is going to be the cost. That's going to depend on how many pizzas we got. Right? And in fact, they tell you that here. And I'm sure below here they put pizza. I just can't see that. So make your scale by 5. And it only goes up to 30. That's nice. What scale should I use here? There's a nice scale for the cost. I kind of pointed it out earlier. What scale should I use for the cost axis?
45.
Yeah, it keeps going up by 45 every step of 5. So it makes sense to use. So this is going to be a very easy graph to make. Let me erase this piece here. All right. So this one is almost too nice of a graph to believe, because they all just, the way that we made our scales, it all just lines up beautifully, right? So, I mean, a long time ago, we were talking about linear growth versus exponential growth. And this is the work we did to show linear growth. So now we're past that. We're even further along. Now we're talking about equations of lines and how does this show up in the equation of the line and so forth. So that's coming up again here pretty soon. Now I can draw a straight line with the help of technology. Wah-ha! There we go. Yay. All right, so let me see if I could do something nifty. Give me just a minute. Let me see if I could do this. I'm going to try to print this screen because I want to bring this back. Let me see if that worked. Whoa. All right, let me see. I can't get that out of the way. Oh, shoot. Has everybody got what they want from that? Can you guys still see the book? Or do you see paint?
You see the book.
See the book. Okay. What can I do? Oh man, this sucks. Let me see. Not sure what to do. Well, I'm gonna have to recreate that later. Shoot. All right. I was gonna try to do something nifty, but it didn't work. So moving down a bit. Find you guys. There you are. Oh, coming back up to here. If you look at your graph, right, what's the Y-intercept?
Zero, zero.
Good. So the Y-intercept is 0, 0. The X-intercept, notice, is also going to be 0, 0. That's the one time that they kind of agree with each other. And then what's the slope of your line? How would you find the slope of it?
How many times it goes up and over?
Yeah, exactly. So don't forget, in English, the slope is rise over run. So if I rise 45 and I run 5, and we already knew this going in, why does it make sense that my slope comes out to be 9? What does 9 represent in this problem?
The price of a pizza.
Yeah, it's the price per pizza. So of course, each pizza I buy makes the cost go up by $9. So of course, we already knew the slope was going to come out to be 9. All right, so let's remember these two things. Y-intercept is 0, 0, and the slope is 9. We're going to need that pretty soon. Now, they do make a good point here in number 5. Right? Do we have to spend all of our money? So let me see. I don't want to get too far ahead here. Yeah, I like it. So we're going to bring that inequality into play here in a minute. Can we actually build the equation for this right now? Can we make an equation that represents the cost for X pizzas? What would that equation look like? So if I've got the cost.
What was the maximum? 175. 175.
Oh yes, we're gonna look at that in a minute, right? Remember we had 175 bucks, so it makes sense we're gonna make an inequality next. But first thing I want to do is, what would the equation be for the cost? Well, what's the slope again?
9.
Slope is 9. So what would the equation be? So each pizza, and I'm going to get X pizzas, I have to pay $9.
C
What
equals
would the- Go ahead.
C equals 9x.
Yes. And again, why does it make sense there's no number here? What number would normally go here? What would the number that would be here mean?
The Y-intercept.
Y-intercept. In the Y-intercept, the Y piece is 0. So that's my equation right there. So now real quick, coming down to number 5. We know the equation now, C equals 9x. And I know I can buy up to $175 worth of pizza. So I need the cost of the pizza to be how related to 175 bucks. Obviously, I think somebody already pointed this out earlier.
Equal or less than.
Good, good. Less than or equal to 175. All right, let me stop for a minute. So do you see how this section is doing interesting things? It is putting together everything we've done so far in chapter 3. It's coming at us. So we've got the table we created. We could plot the relationship between pizzas and cost. We can then create an equation that I can use. So how would I use that now? I know C is 9x. Can you guys put that in here and solve the inequality for me? Right, we know that C is 9x. So if I put that in, and solve that bad boy, let's see what we get. All right, so let me catch up to you guys. So I know the cost is 9x. And of course, what do I do to solve that?
Divide.
Divided by 9.
Divided by 9, I like it. That's not going to go in evenly.
19.444.
19.444. So that kind of relates to, I think it was Vu said this earlier. We know it's got to be less than 20. So if I want to put this in real life terms, what is the most pizza I could buy if I don't pay any tip?
19 boxes.
19 pizzas. I love it because it's got to be less than or equal to 19.44 pizzas. And I can't buy 0.44 of a pizza. It won't let me do that. All right, let me stop a minute. So back in that inequality section, somebody asked me during office hours, they were like, why do they keep asking me to interpret my results? Because that's the most important thing in real life. You do the math and you get a number and you get a variable and you're like, okay, you got to know what that means or else it didn't help you at all. So in this case, we can buy at most 19 pizzas. Mathematically, I can get a little bit more, but in the real world, we can't do that. Sorry, math. I like it. Now, let me do this. I think I want to transition to the board. It might be easier to do it. What I want to do next. Let me make sure everybody's got what they want from that. I kind of just want to get up to. If I get up, maybe it won't be quite so cold. All right. Has everybody got that? Anybody still copying from there? I'm gonna clear that. I'm gonna stop sharing. Okay. So let me recreate that graph we just made. Make sure you guys can see this. Wow, I'm really close. There we go. Okay. So we have our equation. The cost is going to be 9 times x. And we made a graph. Let me just do a few of these. All right, so we got this bad boy. Yeah, sure, this is fine. Bump, bump. Let's see how good my scale is. Bump. Bump. Okay. Oh boy, my scale's a little bit off. That's all right. Make them big, make them big. All right. All right. So this is pizzas, number of pizzas. And this is cost. Now, what if we decide to be good human beings and we say, man, this delivery driver's coming out here. I really should give him a tip, right? And let's say that we decide no matter how many pizzas we're going to buy, we're going to give him, I want to give this guy a, let's say, $20 tip. No matter what, we're going to just give him 20 bucks. What is that going to do to my equation? And what is that going to do to my graph?
Is the equation going to be plus 20?
Good. So the equation, the cost now not only includes the pizzas I've got to buy, but now I'm going to give on top of that, I'm going to give 20 bucks. I like it. So what about graphically? What's going to change?
It no longer intersects at 0, 0.
Yeah, it doesn't intercept at 0, 0. Let's see if we can do this without making a table of values. So what's going to happen is if I get, now this is the weird part. If they come out to me and I don't buy any pizzas, I shouldn't have to pay any tip, right? Well, let's say he comes out to me and I give him a tip and we decide we don't want the pizzas. We're kind of crazy people. So now it's going to be at 20. So let me kind of estimate that. Is it going to change how much it goes up if I now get 5 pizzas? If I get 5 pizzas, how much is the price going to increase by?
$20.
Say again, sir.
$20.
No, the $20 is a set amount that I'm giving no matter what. What part of this equation changes if my number of pizzas change?
The X.
Yeah, this part. So if X is 0, I get 20. If X is 5, what is this piece? If I get 5 pizzas. 45, and then I'm going to add 20 on top. So now it's not going to be 545. It's going to be 565. In fact, can you see what's going to happen to every point? What's the simple thing that's going to happen to every point on this line. It's not going to be where it is. It's going to be where it is
Plus 20.
plus 20. So every point is going to go up about 20 bucks. Every point's going to go up about 20 bucks. And what's true about those two lines? Can somebody tell me geometrically, who remembers, do those two lines ever meet? Are they ever going to meet each other?
No, they're parallel.
No.
They're parallel. I love it. So I've got this equation before I decided to be a good person. And then I've got this equation after I decided maybe I should do something nice so my karma is good, right? Notice, of course, that they both, what's the slope of both of them?
9.
9. So the slope doesn't change. It's just that where they start changes. So of course, if I have two lines that have the same slope, they're going to end up being parallel to each other if they have a different y-intercept. So that's how I can tell just from equations, if two lines are parallel, all they need is to have the same slope and a different y-intercept. Right? If I gave a higher tip, that would just make the blue line move up more. It would go up at exactly the same rate because the 9 wouldn't change. I like it. I like it. Okay. I like it. So that's the extra little point I wanted to make with this problem. Okay. Let me double check. I think there was one more thing I wanted to do with this before we get into blood alcohol level. Here we go. Nope. Yeah, here we go. Yeah, now, yeah, there's one more thing I wanted to do. I love it. If I draw, here's something interesting. So we can start to answer the same questions we answered earlier. Remember we had about $175 to spend? Remember that was our budget? The 175 bucks was how much money we had total. Watch something interesting I could do graphically. Where's 175? It's about right here, right? Now, some of you guys in the last section, you had to do this for the homework. You had to identify on the graph the part that matched up with the work you did. And you just had to identify where the point was. So here, if I look at 175 and I just kind of draw. So there's this point right there. What does that relate to that we found earlier? Now, this is a really interesting question. What work that we did earlier does that point relate to? That's $175 right there. And this was our original line. What does that relate to? It's just below 20, right?
The amount of money we had to spend.
Yeah, so we had 175 total dollars. So how many pizzas did we figure out earlier that we could get up to? Up to how many pizzas? The work we just recently did.
20.
Not quite 20.
19.4 pieces.
19.44. Remember that? That is 19.44 right there. Right below 20. So if I draw 175 over, I can see graphically, I can see what the answer is going to be roughly, which is exactly what an earlier section had you doing in the homework. Not everybody's gotten there yet, but this is going to happen to you very soon. So give me an estimate. What if I include a $20 tip? That would mean that it would be right here. So if I estimate that, it looks like it's closer to 15, right? If I had to estimate it on my crazy picture, I'd say around 17 bucks. Or I'm sorry, 17 pizzas. So let's verify that. I don't know if you guys are with me. So earlier, The work I'm talking about right here is when we said 9x had to be less than or equal to 175. And then we did this and we got 19.44. Can you guys do the similar work using this fact? Let's now say the cost is this. I still have $175 to spend. Can you set up that inequality and solve it for me? Same way we did this one. So I still want the cost
Yeah,
to be at most $175, but now I'm saying, let's use this situation instead.
so it's 29 divided by 175. Simple as that. No big deal. It's 29 divided by 175. Should be.
I could hear Linnell's thoughts. It's kind of neat. So what am I going to put right here now? What situation am I in? I'm assuming it's not just this. I'm also going to
$29.
tack on, huh?
29.
No, be careful.
9x plus 20.
9x plus 20.
29.
Now, how do you solve that really is the question. What do you have to do first, of course, to solve this?
Subtract 20 from
Subtract 20. So now I get 9x is at most 155.
Oh, that's where I got twisted.
And then, of course, the last step is to
divide.
divide by 9. It's still not going to go in even, but it almost does.
17.22.
See again?
17.22.
17.23. That's not bad. Remember, what was our estimate from my crazy ass picture here where the slope isn't really beautiful? It was roughly about 17, right? I could see what my limit was. And so that told me how far on this line I could go. That is the most I can go. It's got to be at most 17.23. Now, of course, since we're talking about number of pizzas, we got a real life problem. We would just say 17. So if I don't pay any tip, I could get 19 pizzas. If I do pay $20 tip, I can get 17
The
pizzas.
cost changed.
I like.
Not the cost, but the amount of you spending. Went down 20.
I like it.
I
All
had
right.
the number, the amount, the cost, not the amount I was spending.
You doing all right, Linnell?
Yeah, you hear me?
Yeah. That's what I make sure I'm not missing any questions. All right.
Oh,
So let's talk about.
I thought I was on mute.
Say again.
I thought I was on mute. I didn't see I was.
It's all good. Thankfully, you weren't saying anything, crazy. Let's see. Let's talk about blood alcohol content. Here we go. Oh, where'd you go? Blood alcohol content. Here it is. All right, sweet. Let me share this with you guys. If it will let me. There we go. All right, so like I told you, this book does get a little preachy, but this is good to know. I mean, this is what happens at various blood alcohol content percentages. So it's blood alcohol concentration. So the legal limit is 0.08%. And you can look into the history of why they picked that number. It is definitely a little bit arbitrary. Number one should not be that crazy. So somebody was found to have 3.5 times the legal limit of alcohol. Can you figure out what her BAC was? So the legal limit is 0.08. Just take a couple seconds if she was found to have 3.5 times that, where would she be in this chart is what I'm curious about. So the legal limit is 0.08. She had 3.5 times that.
That's
Yeah.
impressive. She was able to drive.
Yeah. Well, it's impressive. I'll take that word. It's a few other things too, but
Right under 0.3.
say it one more time.
Right under 0.3 is 0.228. 0.28.
Yeah, 0.28. I love it. So if you do 3.5 times 0.08, let me see. So it's number one is not that big of a deal. So it's 3.5 times 0.08. You end up with 0.28. So she's right in between these two. She might have passed out, tremors, memory loss, cool body temperature, the cool body temperature. But the memory loss and the possibly passing out doesn't really go well with driving. I like it. I like it. Okay. So that's one little thing. They just want to throw that in. Now, I love this. So John
like
Q.
that name.
Bonehead. I know. I love it. They do get a little preachy. Decides to drive when he shouldn't. Now, this is where we get something interesting. This is what I was talking about earlier, and this is Vu's. I think, Vu, you said that you thought it left the body at a constant rate. So it's interesting. Once you get your blood alcohol content or concentration up to a certain level, how long does it take for it to leave the body? So this table shows what the blood alcohol content would be if you started at 0.16. So can somebody tell me, is it leaving the body at a constant rate? Is this linear pattern that we see here? And to even push it a little further, can somebody tell me what the slope is, if it is linear?
Yes, it decreases by 0.015 every hour.
Yeah, so if you do each step, it does go down by 0.015. So you can kind of double check that yourself. All right, let me stop for a minute. There was a section that we did earlier where a big chunk of the work we did was basically like this. Remember the linear versus exponential growth or decay? So in this case, it's not linear growth, it's actually linear decay, right? It's the amount is going down over time. So what would the slope actually be then? Can somebody figure that out? Let me put it where it goes here. So slope is going to be the change in y over the change in x. So how big of a step does y take versus how big of a step does x take? So for every how many steps in x does y change by how much? So here, how much did x change here?
1.
1. And it changes by 1 every time. And so that's the change in x. And how much does y change at the same time?
0.015.
And the one little thing you got to add in there that I didn't put here, is it going up or down that much?
Down.
Down. So it should be negative 0.015. So you should be able to right now, especially after you answer this question here. So I'm going to leave that question up there. That's going to help you. I want you to come up with the equation that shows me the relationship between blood alcohol concentration and number of hours after 2 a.m. for this John Q. Bonehead of the clan Bonehead. And again, remember, I'm not going to see this work. So do what you can. So you know the slope. You should be able to figure out the y-intercept. And then you should be able to put the equation together. All right, let's see. Who's got that figured out? And I don't know what variables, you guys could pick whatever variables you want to. So you could always just use Y and X, that's fine. I'm going to use B for blood alcohol content, and I'm going to use T for number of hours after 2 a.m. Right? Does somebody think they have the equation put together?
If we're using your variables, I guess it'd be
Sure.
B equals negative 0.015 T plus 0.16.
Good, because the y-intercept is right there. The y-intercept is 0.16. So this is going to be 0.16. And I know that part of your brain, for some of you guys, probably doesn't like all the decimals in there. Go ahead. Sorry.
Oh, sorry, I'm still.
Oh, okay. So that's beautiful. That's perfect. And again, you didn't have to use the letters I chose, right? They didn't really tell us what letters to use here. But let me stop for a minute. Is everybody cool with that? We've done that a few times by now. We can find the slope. We can find the y-intercept. And then I can put that in the equation. Why does this make, just to remind you guys, why does this make sense? If in the equation, if I make T 0, what do I get for B? If I make T 0 in this equation, what do I get for B? So that would be negative 0.015 times 0 plus 0.16. So what would I get?
0.16.
0.16, I love it. Which matches up with when T is 0, I should get 0.16, and I do. So that's why it makes sense that this is going to be whatever the output is. It's going to be the intercept related to the intercept, because when this variable is 0, this is the only thing that's left. Okay, I like it. All right. So I'm going to clear this. I want to see what else they ask us to do this equation. Actually, let me show you this. I'm going to clear this. Has everybody got what they need from this? Okay. And then I do want to show you, let's fact check the book a little bit. I found a couple of articles that talks about this, but here's one right here. Blood, how long does alcohol stay in your system? Look down here. Virtually all humans metabolize alcohol at a constant rate of 20 milligrams per deciliter. What the shit? Or 0.015 blood alcohol concentration every hour. Isn't that exactly what we just found? So the book did a good job of looking that information up. Right? Why does it say virtually all humans? Because everybody's a little different, right? Some of us might have some special ability with alcohol, and some of us don't. All right, I just want to show you that. It's kind of cool. I was
Actually,
kind
I
of
think
happy.
women, and I think Asians are missing an enzyme that keeps it hard to metabolize alcohol.
See, that's
So
interesting.
Yeah.
I was
So-
curious if there
Yes,
were
I
any.
thought I had a special ability with alcohol until I learned different.
It sounds like you had a personal experience that showed you different. I understand. I understand. I can relate. But let me see. And that's interesting, Vu, you brought up that point. The equation of the line we just created could be different for different groups of people. That's kind of interesting. But the one we created is probably sort of an average for everybody, right? It's sort of like, does everybody understand that 98.6 degrees is not necessarily your baseline temperature? It's not even the right average anymore for people, but used to be. Yeah, okay. If you didn't know that, you probably, if you're feeling completely great, you should probably take your temperature and get your baseline. So you know what a true fever
Is the average lower or higher now?
I think it's higher, but I can't remember the last time I checked.
Huh. All right.
Yeah, I run colder. I run a degree colder or something.
Yeah, exactly. And I run a little bit hotter, I found out. So I don't really, fever for me doesn't start until a little bit higher. I think I normally run like 90, almost 99. So 98.9 and 90. So if you have a kid, you really want to know what their baseline is, so you don't freak out if they're run high normally. Anyway, okay. So let me stop sharing this. Bam. Let me see what else this book does with this information. All right, we already did that. I like it. Oh, okay. So let me ask you this. So let me bring this back up. And of course, now this is all gone for me, so I have to recreate it real quick. Just somebody help me out. I think the equation we got was B equals negative 0.015 T plus 0.16. Yes, okay. Can you guys take a minute and figure out when his blood alcohol concentration will be 0? Figure out when the BAC will be 0 for Mr. Bonehead.
Hey, Bone.
Just so you guys know, tomorrow I'm going to have like a little review worksheet that we're going to work on the stuff we've done in chapter 3 since the last quiz. All right, so let me make sure everybody's doing this correctly. You're definitely going to want a calculator to help you out on this one. Why is this different from the pizza problem? The answer we get is actually exactly the answer we need. It's different from the pizza problem where we had to adjust the answer we got. So what is somebody doing? Can somebody tell me what's the first step to answer this question?
Replace B with 0.
Yeah, if I want the blood alcohol concentration to be 0, I kind of love this. It's the idea of make this 0 and then force this to tell me what it is. So if I make this 0, I can then solve for T, and it has to tell me what it's going to be to make that happen. All right, so let's see. I'm really curious how long this guy's it's going to take for him to sleep.
You want
this
the
off.
answer?
Well, let's see now. So what's the steps to solving this? What am I going to do first to solve this?
Subtract 16 or 0.16.
Yeah, so I'm going to subtract 0.16 because my variable is right here and I want to isolate where my variable is first. So I'm going to subtract 0.16. And then, of course, what's almost always the last step?
Divide 0.05.
Yeah, so be really careful. Remember, I talked about the fact that our brains sometimes want to add because it sees the negative sign, but it's the operation that we have to pay attention to. So I'm going to divide by this because it's multiplying. So then I get t is whatever this is.
10.6 hours.
Yeah, it sounds about right. Is it 10.6666?
Yeah.
Yeah. You guys with me? So that's if you knew your blood alcohol concentration, you could then figure out how long until you're completely no alcohol in your system. There will still be alcohol in your urine for like, I can't remember how long now. And, you know, if you overload your kidney, blah, 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 all kinds of weird stuff happens. What about this? Let me ask you another question using the same equation. How long would it take for John to be street legal? What does that mean? What's the legal limit? Who remembers that?
0.08.
0.08.
Yeah, the legal limit is 0.08. Right? So let's do that one together. This should be pretty quick. Everybody's got this here? Anybody had trouble with that? Okay. Let me kind of erase some key parts here. Blah, 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 blah. So the steps I'm going to take are going to be basically the same steps, right? Still going to try to get t by itself. Let's see how long until John can legally get on the road. So now what am I going to put here?
0.08.
0.08. I like it. So I'm still going to do the same steps because the steps don't care what that number is. And subtract 0.16. That's kind of nice. 8 minus 16 is negative 8. So I get negative 0.08. I like it. And obviously this is going to be less than 10 hours. 10 hours is roughly when he's got all the blood alcohol concentration is just about 0. So now I just want to get it down to 0.08. This should be quicker. So when I do that last step, the last step is almost always divide. This is I'm very curious now. How long is it until this guy can hit the road legally?
About 5 hours, a little bit over 5 hours. So half the time.
5 hours?
5.3.
Yeah, 5.3, exactly. So, and Vu, you just made my point for me. I love it. If he starts at 16 and it takes like 10.666 hours to get to 0, to get halfway, you can stay with me, wouldn't 0.08 be kind of like the halfway point to 0, right? From 0.16 to 0.08 to 0, that's kind of like the halfway point. This is basically what we just said. So of course I should expect it to take half as long, 5 1/3 hours to become street legal, right? So if at 2 a.m. he's got, go ahead, sorry.
Right, because the rate's constant.
Exactly, because the rate's constant. That's exactly why that works. If the rate was not constant, if this was exponential or this was parabolic or something, I couldn't do that. It is because it's linear, because it's a constant rate. Does that make sense? You guys with me? So to get all the way to 0 took 10.6 hours. To get only halfway would take half as many hours. That makes sense. I like it. I like it. Okay. Okay. So let me clear. So now I really want you guys to understand what's happening. We are able to construct equations from a table, from a graph, from information we get. And once we have the equation constructed, we can do all kinds of things with it. We can figure out stuff in the real world. These are real life situations. How long does it take until I can hit the road legally? Well, now I know it's a little over 5 hours. Roughly, right? Now, John's equation might be a little different because of ethnic group he belongs to or genetics, right? But this should work for a rough estimate. So to be careful, what should John do? If he does this equation, or maybe has somebody else do it for him because he's got freaking 0.16 blood alcohol. So he probably can't think straight. But if a mathematically minded friend of his, stay with me, figured out it would take this long from this equation, he should probably wait how long? Until he starts driving.
Play it safe over 5.3 hours.
I would say about 6 hours, right? Just to kind of guess. I would wait 6 hours just to be a little more sure. I like it. This is beautiful. So this is something about equations in mathematics. The equations we come up with are sometimes broad equations that don't work for specific situations. So John's equation for himself could be different from this because of his genetics, because of his ability to synthesize alcohol, because of so many things. But the equation does a good job of getting an estimate, and then we just, to be conservative, we're going to wait a little bit longer. Okay, I like it. I like it. So let me clear all that. Anybody still copying that stuff down? You guys good? All right, I'm going to clear that. Pop. All right. Blah, 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 blah. Yeah, yeah. See, we just did number 10 there. Okay. Shoop. All right. I want to look ahead. Let's look at what the homework is going to look like, so you guys aren't too freaked out. So you should expect a situation like this where they give you information. You've got to write an equation, right? Real quick, if you read through this, let's read through this. Can somebody point out to me, if you read through this first problem out, Bubba, can somebody figure out what the slope is? Trust me, this is going to happen to you. Can somebody see what the slope is?
0.4.
Yes, good. Why? How do you know that's the slope?
0.1 per month. So per each.
Yeah, good, good, good.
Yeah.
So
per
Linnell, this
month.
is great. Go ahead, because we talked about the per word was important, right? So that is a rate. They tell you it's a rate directly. So, and I know that slope is a rate of change. What's the 170?
The Y.
The Y-intercept, because that's the initial starting point, right? Which is very often what the Y-intercept represents. Not always, but most of the time it represents an initial point, so where we start. And then the slope is how we change from that. All right, I love it. And from those, you should be able to set up the equation. Let me see, blah, 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 blah. All right, and then once you've got the equation set up, you can answer a lot of these questions pretty quickly. Draw the graph. You'll be able to do that with the equation. All right. So nothing looks too weird yet in the homework. Now they give you a chart, a table. So like I said earlier, you should be able to set up an equation from information they give you. You should be able to set up an equation from a table they give you, right? Does this look to be linear growth? How would you tell? Whoa, holy shit. All right, there we go.
Yes,
How could you tell? Sorry, go ahead.
looks like you're losing 4. What is it?
He's losing 4, but what's important also is he's losing 4 for what?
Per 14, not per 20.
And be careful. What does this column here represent?
Oh,
Is that
this
14?
is
What is that? Go ahead.
28. So that's exponential. What is that? When you move it,
Now be careful. It's not exponential because how much do the calories change by?
Every 14 calories is 4 pounds.
And don't get too excited. It's 14,000 calories, right?
14,000.
So every 14,000 loses 4. Every 14,000. So these 4s should be negative. I like it. All right. I don't want to do too much of this for you, but you should be able to get the slope and the y-intercept from the table. And once you get those two things, you can make the equation just like we've been doing. I like it. And then, of course, probably as soon as you create that equation, they will ask questions about his weight. And the nice thing is once you got the equation set up, you just plug the numbers they give you in the correct place, just like we did earlier with the blood alcohol content or concentration.
Jeff, you said something about linear. Can you go back to that where you was at? To the graph?
Yeah, this guy?
Yeah. So what was
Yeah.
the question you asked at first?
My question at first was, how do you know this is linear growth?
Okay.
And I know it's every time this goes up by 14,000, this goes down by 4. Every single time this changes by the same amount, right? Do you remember that? In exponential growth
Right.
would have been they get multiplied by some amount.
Yeah, I seen the 4. I just didn't. I didn't put the by the 14. So I thought it was something else when you said that. So yeah.
I got you.
Come on.
All right. I'm with you. All right. Coolness. All right. Let me clear that back out. All right.
Hey, Jeff, what I missed,
So
I
this-
got booted out for about a minute.
Oh, that was you. Okay. That's all right, Vu. I understand. All right. So this section 3.7 is really nice because it finally brings together a lot of the little pieces we've been talking about. And I'm hoping it's not going to be too insane because it's got little elements we've already done a few times over. Let me point one thing out. I think this is where they finally catch up to us. Sorry. Here we go. Right here. We've known about this little dude here for a while. And it's kind of nice. A lot of students like to have kind of a framework to work in. Did I ever tell you the kind of the urban legend about why this is M? So M is the slope. This is not a very interesting urban legend, by the way. This would be a very boring movie if they made it. But the idea is it's because of the French word marcher, which means to walk. So you can think of a slope as how somebody is walking along a line. So they think that's why we use the letter M. We're not really sure. Go ahead. Sorry.
Are you talking about the fly?
As far, say it one more time.
Are you talking about the fly? Like what?
Oh, the fly thing was when Descartes was sick and he was staring at a ceiling. Is that the one you're talking about? And he
Yeah.
imagined Or, like somebody watched the debate and saw a fly walking around and somebody said, and they said, well, I could use like the left and right motion and the up and down motion to describe where that fly is. That's what you think about was good old Descartes. There
Yeah,
are a
that's
few
awesome.
urban legends in math. None of them are going to make a great movie, right? But they're still out there. So this equation we've known about for a while, and the book's finally caught up to us now. All right. Okay. So like I said, tomorrow we are going to have a little like review sheet to work on. I'll probably let you guys work on those in little groups. Just so we're up to date with everything, because I come ready tomorrow with questions from 3.4 and 3.5. If you're still working on the early part of chapter 3, you probably want to let that go for the moment. You always want to kind of keep up with the current homework so you're ready for the next quiz. Okay, and just to look ahead a little bit, just to see where we're going. Yeah, so now we're going to be talking more about other forms of lines. So we got our y equals mx plus b. There's at least one more form of a line we're going to talk about that's more useful in different situations. So that's what we're going to get into in 3.8. Otherwise, I think that's enough for today. Let me know if you need to hang out. And by the way, guys, let me see. Did you notice? I think he's left. Is Carrie still here? No. Okay. Did you notice there was a new student today? That was one of my colleagues. So he was here evaluating me. So that was exciting for me in this environment. But anyway, anybody have questions and need to hang out? Otherwise, you're free to leave.
Bye.
All right, guys. I'm gonna head out. Y'all take it easy.